welcome to Gifted Dance Science and Technology Physics class. My name is NC Joshua. Today we'll be looking at simple harmonic motion. Now, what is simple harmonic motion? Is that motion where the object goes to and fro, front and back, passes the equilibrium point as it goes to and fro. So, some people calls it a to and fro motion. Is a simple harmonic motion. Now, take a look at this example that I want to illustrate. This is a spring attached to a block or a box. Now at this point, the spring is not stretched. So it means that the block is at equilibrium. Now at this point, the block was displaced to this point. So you see the displacement. The block was displaced to this point. On leaving the block here, there was a force that tends to pull back the block or the spring towards the equilibrium point where it was before. This force is called a restoration force. So a restoration force is that force that brings back the object towards the equilibrium point. Now remember, displacement was in this direction. The restoration force was in an opposite direction. So the force and the displacement are not in the same direction. So I can say that F is proportional to X. Leaving it as X will not be nice, but adding a negative sign shows that the displacement and the force are in opposite direction. Now, according to Hooke's law, force proportional to extension. What is the next? F is now equal to minus Kx, where K is the elastic or the spring constant. Now, what's the next thing? Now, from this place, we can tell that force and displacement are directly proportional, but opposite in direction towards the equilibrium point. That is enough to define a simple harmonic motion. So we said simple harmonic motion is that motion whose force is directly proportional to the displacement. Force is proportional to displacement, but opposite in direction towards the equilibrium point. So the force tends to pull the block or the box back towards equilibrium point. So this is what the formula is saying, and we have used this to define simple harmonic motion in terms of force and displacement. Now bring this formula here. If F equals minus Kx, recall, what are we recalling? F equals mass times acceleration. Therefore, I will now have, in place of F, I have mass times acceleration equals minus Kx. Remember, the negative sign is showing us it is opposite in direction. What will now be this? Now watch, now I have A is equals minus K over M X. Now what does that mean? A is proportional to X in this equation. A and X are directly related. So I can still define simple harmonic motion in terms of acceleration and displacement. Remember, this was in terms of force and displacement. Now I want to define it in terms of acceleration and displacement. So therefore, what is simple harmonic motion? Simple harmonic motion is that motion whose acceleration is directly proportional to the displacement. Acceleration is proportional to displacement, but opposite in direction towards the equilibrium point. So now we have defined simple harmonic motion in terms of acceleration and displacement. And also we have defined simple harmonic motion in terms of force and displacement. So we have done that. This is for force and displacement, while this is for acceleration and displacement. What are some examples of simple harmonic motion we have? The motion of a swinging pendulum bob, is an example of simple harmonic motion. The motion of a vibrating piston in a car engine is an example of simple harmonic motion. The motion of a loaded test tube vertically in water is a simple harmonic motion. The motion of the heartbeat is a simple harmonic motion. Now we're looking at terms associated with simple harmonic motion. The first term we'll be looking at is the equilibrium point, also called the mean point. Also called the mean point. Now, what about this point? This is the point where there is no net force acting, no net force acting on the object. The object is at rest. So F is equal to 0. At this point, F is equal to 0. No force is acting on the bulb. Then also at this point, displacement is equal to 0. There is no displacement at all. So when the bulb is at rest, displacement equal to 0, net force is equal to 0. At that time, the bulb or the object is said to be at equilibrium. Now let's look at another term associated with simple harmonic motion, which is amplitude. Now remember, if this bulb is at this position, we said x is equal to 0, which means that the bulb is at rest. But when you apply a force, the bulb goes here and has the tendency to swing back here. So we can have this bulb here. We can also have it here. Now, what is this showing us? It's showing us that when you apply a force, this is the highest point it can get to. So we say at this point, the bulb has reached its maximum displacement. So x here is equal to maximum. Also, when it swings and passes the equilibrium point, it goes to this extreme again. This is the maximum it can get to. So at this point again, x is equal to maximum. So now amplitude is the point of maximum displacement. So that means if x is maximum, it means that x has attained magnitude. So I can still say that x is equal to a at this point. While here I can say x also is equal to a. So this is how amplitude is being actualized in such a swinging pendulum. What about in a sinusoidal curve? If I have a curve of such, this curve started from this point. This curve started from this point. So as it goes up, this is the maximum place it can get up to before it starts damping down. So from here to this point is called maximum displacement, which is amplitude. As it goes down, this is the highest point it can go before it rises up again. This point to this point again is referred to as the amplitude. So this is maximum displacement from here to this point is maximum displacement upward. From here to this point is maximum displacement downward. So maximum displacement is what we call amplitude. Remember, maximum displacement is gotten at the extreme, not at the middle. At the middle, x equals 0, but at the extreme, x is maximum. Therefore, x equals a. A here stands for amplitude. Now we have another one, which is period. Period is big letter T, and we said the period is the time taken over the number of oscillation. Time taken over the number of, so the time taken to complete an oscillation is called the period. I repeat again, or I reiterate again, the time taken to complete an oscillation is called the period. The SI unit for period is seconds, but the SI unit for amplitude is meters. Now, what is the formula for period? This is the formula for period, which is period equals time taken over number of oscillations. So N indicates the number of oscillation. Now, what about frequency? Frequency is the number of oscillation per unit time. Now, look at this. I can have a bouncy ball and I can bounce just 5 times per minute, but I can also increase it to become 10 per minute. So now the number of oscillation per unit time is what we call the frequency. And the SI unit for frequency is hertz. The SI unit for frequency is hertz or per seconds or per circle or per circle. It's very important to know this unit. It's hertz or per seconds or per circle. Now there is a relationship between period and frequency. What's the relationship? Period is equal to the reciprocal of frequency, and frequency is also equal to the reciprocal of period. They are inversely related. That's why you can see that period is t over n, but frequency is n over t. They are inversely related. Now we're looking at some questions that are tied to some of these ones that we have discussed so far. Now let's look at number one. A boy timed 30 oscillations of a certain pendulum thrown and obtain 1 minute 10 seconds, 1 minute 12 seconds, and 1 minute 7 seconds respectively. These are the time taken, and this is the number of oscillation. So we have first, second, and third, and so he said we should calculate the mean period. The mean period. So solution to number one will be for the first. What is period? For the first, number one, I have period equals the time taken over the number of oscillation. So it's equal to, what's the time? The time is 1 minute 10 seconds. 1 minute 10 seconds will be 1 minute 10 seconds over n. So I have my T1 will be 1 minute is 60 seconds plus 10 seconds over 30, which will now be equal to 70 over 30. This cancels this. We'll now have 3 into 7 is 2. 2 point, you have 1, it will be 2.33. 2.33 seconds. That's the first one. What about our T2? Our T2 is our T1. What about our T2? Our T2 will still be equal to T over N, which is equals. What is our time for T2? Is our time for T2? It is now 1 minute 12 seconds, which is now equal to 60 plus 12 over 30. So this will now be equal to 60 plus 12 is 72. I have 72 over 30. Now, if I want to take this off, I'll bring in a dot here. Then 3 here, 1. 3 into this will be 2. Point remaining 1 into 12 will be 4. So my answer here will be equal to that. My T2 is equal to 2.4 seconds. What about my T3? My T3 is equal to the same T over N is equal. What's my T3? The third time was 1 minute 7 seconds. 1 minute 7 seconds, that was to be 60 plus 7 over 30 because n is 30. 30 oscillation. That will now be equal to 67 over 30. Take off the 0, bring the decimal point in. It will now be equal to this into this is 2 points. This into this again is 2. Remember 1 into that will be 3, 3. So our T3 is equal to 2.233 seconds. Now, what is not the mean period? My mean period, this is a mathematical statement, will now be equal to my T1 plus my T2 plus my T3 all over 3. So question is, what is my T1 equal to? My T1 is now, that's 2.33 plus, what's my T2 plus 2.4 plus, what is my T3 plus 2 point, that's 2.233 all over all over 3. So when we divide that, we'll now be having total answer will be 2.321 seconds. So because it was mean, I had to use this to multiply. Sorry, because it was mean, I have to add up the 3 and divide it by 3. So the final answer is 2.321 seconds. Now, what about question number 2? Question number 2 says, two simple pendula X and Y makes 400 and 500 oscillation in equal time if the period of oscillation of X is this. So they gave us the period, we should find the period of Y. Now remember, period of X is equal to the time taken of X over the total number of oscillation, while the period of Y is also equal to the time taken of Y to the number of oscillation. Now they said that the two pendula X and Y has, this is their number of oscillation in equal time, in equal time. So it means that our Tx is equal to our Ty. That's what it means. Our Tx equals our Ty. So if our Tx and Ty equals T, because they are equal, I can make them the subject formula. So what is Tx? Tx is equal to period of x times n of x. This is n of x, while this is n of y. What about my ty is equal to period of y times the n of y. So if this equals this, if tx equal ty, so I will now be having t period of x times n of x is equals period of y times n of y, because my tx equals my what now? Equals my ty. So and my tx is this and my ty is this. So if this equals this will equal this. Now, what is my tx? That my period of x is 1.5. So I have 1.5 times the number of oscillation for x. X comes first, so x will be for 400 times 400 is equals ty times 500. So this cancels as this cancels as this. Now, if I want to do this, 5 here will be 1, 5 here will be 0.3. 0.3 times 4, so I have 1.2 is equal to ty. Therefore, my ty is equals 1.2 seconds. So that's how this is solved. Most times when you are calculating, please look critically at the statements. Why? Because they are very important. Because in the statements are the technicality you need to answer this question. Now let's look at energy of a simple harmonic motion. Now, when you have a swinging pendulum of this nature, there are energy changes that occurs as the pendulum ball swings to maximum, comes back towards the low point. This is the equilibrium point, and back to maximum again. There are energy changes that occur, but the total energy, which is the mechanical energy, is equal to the potential energy plus the kinetic energy. So I will now ask myself, what is the total energy? The total energy here is given by 1 over 2, 1 over 2 Ka square is equal to, what about potential energy? Potential energy here is not mgh. Take note, it's not mgh. No, rather it is 1 over 2 Ks squared. That's the energy in a spring. Hooke's law tells us about this, that the energy stored in a spring is 1 over 2 Ks squared. Now, plus, what about this? This is 1 over 2 mv squared. That's the potential, that's the kinetic energy. Now, collect light terms. What do we have? 1 over 2 ka square minus 1 over 2, this come over this place, ks square is equals 1 over 2 mv square. Now what is common here is 1 over 2k. So I have 1 over 2k, open bracket, and I have a square minus s square is equal to 1 over 2 mv square. 1 over 2 cancels out 1 over 2. I'm now left with, now please look at this, I'm left with k over m. K over m will now be equal to a square minus s square. K over m is equal to, k over m bracket, k over m bracket a square minus s square minus s square is equal to, what's it equal to? Is equal to mv square. Now, is equal to v square? Is equal to v square. What will not be v? Therefore, v will not be equal to square root of k over m dot square root of a square minus s square. Now, what is this? Now, take note, this you see here is equals angular frequency. I will show that to you in a moment. So, if square root of k over n equals angular frequency, therefore V is now equals angular frequency square root of a square minus s square. Now, this formula is very important. Why? Because it's used to calculate for the velocity of an SHM. This is the velocity of SHM. Take note of this, very, very important. Now, let me show you this in a moment. Very, very important. Let me show you this in a moment. Now, remember that we said recall. What do I want you to recall? I want you to recall that A, that F is proportional to x minus x. Then we now said f is equal to minus kx. Then we now said f is equal to mass times acceleration equals minus ks. Then a is now equal to minus k over m x. Now remember how we got here? Then now let this be equation 1. Let this be equation 1. A equals minus k over m x, equation 1. Also recall, what do I want to recall? That centripetal's acceleration, also recall that centripetal's acceleration. What about centripetal's acceleration? Centripetal's acceleration, which is A, is equal to v square over r. That's centripetal's acceleration, where v equals wr. Therefore, centripetal's acceleration is equal to angular velocity times arrow dot angular velocity times arrow over arrow, because it's v squared. That's why I'm having it like this. This cancels as this. I now have centripetal's acceleration is equal to w square arrow. Now, if arrow equals displacement, arrow is radius is displacement. Therefore, what is now centripetal's acceleration is now equal to w square x, equation 2. Now remember, my equation 1 is a equals minus k over mx. Now the minus sign is just showing opposite in direction. So now I will now recall equations. What do I want to do now? My first equation is a is equal to k over m, all in bracket x. That's equation 1. Also, a is equal to, now w square x, equation 2. Now, if you look at equation 1, equation 2, A is equal to A, X corresponds to X, therefore W square will correspond to K over M. So from the equation, I can say that W square is equal to K over M. Therefore, what is now W is now equal to angular frequency is now equal to square root of K over M. This K is called spring factor, while the M is called mass or inertia factor. Mass or inertia factor. So you see how I got that angular frequency is equal to square root of spring constant over mass constant or inertia factor. Now look at it now. If you now look at this place, you now see why I replace square root of K over M, I said equal to W. So take note of this. It's very, very important that all these are very nice questions in the solving. I hope you can still remember that angular frequency equals 2 pi f. So if angular frequency equals 2 pi f, this is another one again, equation 1. And I know again that 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 this that W equals 2 pi f. And I know that angular frequency equals square root of, K over M. So if this equals this and this equals this, I can still say this equals this. So I can say that 2 pi f is equal to square root K over M. What will now be f? F will now be equal to 1 over 2 pi root K over M. That is frequency. We can use this to solve for frequency. Now, if T period equals 1 over frequency, therefore, what will now be period? Period will now be equal to 1 over everything here. Period will be equal to 1 over everything here. What will that be? That will now be 2 pi square root of M over K. Now take note of this. This will be used to solve for period, while this can be used to solve for frequency, where you understand all of these things that I have proven on the board. The formulas are very simple and the analysis are also simple very well. So you see questions where you will be warranted to use this formula and questions where you want to use these formulas. They are very important. Now, I want you to follow me strictly as I show you how simple to detect where all of these energies are maximal and where they are minimal. Now, let's look at this. Recall, we have V is equal to W square root of A square minus S square. We just proved that not quite long. Now, at the middle, look at what I want to do at the middle. That's at this point. Remember, at this point, x is equal to 0 because there is no displacement. At this point, that's equilibrium point, x equals 0. So at the middle, x is equal to 0. Therefore, what is v? V is now equal to w square root of a square minus 0 square. This will now be v equals wa square. V equals w times square root of a square. This cancels as this. So v equals wa. Now A is showing that it's maximal. Remember, A is maximal displacement amplitude. So A showing in this formula shows that velocity is maximal. Where is velocity maximal? Velocity is maximal at the middle. Why? Because x equals 0. So at the middle, x equals 0 and velocity is maximal. Take note of this. I have just so anywhere you see A coming out in the formula, it means that is maximal. Now, what about at the extreme? At the extreme, what is happening at the extreme? At the extreme, remember when this bulb goes this direction, x is no longer 0. x is now maximum. And what does that mean? It means that x is now equal to a. Now, mind you, whatever affects this side will always affect this side. These two sides are equivalent. So whatever we use here, we use there also. So at the extreme, x is equal to a. So I will say at the extreme, x is equal to a. If x equals a, bring down this formula again. Therefore, v is equal to angular frequency square root of a square minus s squared. So if x equals a, I will now have therefore v equals angular frequency square root a square minus a square. A square minus a square is 0. So v equals w times 0 equals 0. So it means at the extreme, velocity is 0, or we use the word minimum at the extreme. Remember, whatsoever happens here, happens here. Whatsoever happens here, happens here. Take note of that. At the extreme, velocity is 0 or maximum or minimum or 0. At the center or at the middle, velocity is maximum. Now, mind you, as this ball swings this way or swings this way, it now has height. Look at it. Compared to the level where it was before, there is height. There is a height. So showing that if there is a height, it means that potential energy is always a energy that involves height. So this extreme or this extreme, potential energy is maximum at this extreme. Now, if potential energy is maximum, anywhere velocity is maximum, that's where kinetic energy is maximum. Anywhere velocity is maximum, that's where kinetic energy is maximum. So at the middle, kinetic energy is also maximum. Now, look at what we've done. We have been able to show some properties if they are maximum or minimum in this particular bulb that swings from the center to the various extremes. Now, remember, we started from x equals 0 because it's at equilibrium, but at the extremes, x equals maximum. And what does that mean? X equals a. Then we now said at the middle, we solved for velocity. We now saw that velocity is maximum at the middle. So velocity is maximum. And we are now saying that any point where velocity is maximum, kinetic energy, because kinetic energy is the energy in motion. So if speed is maximum, kinetic energy will be maximum. And if kinetic energy is maximum at the middle, then we now said that velocity is minimum or 0 at the extremes. So velocity is minimum or 0 at the extreme. Then we now said if velocity is minimum, it means potential energy is maximum at the extreme. So if you see at the extreme, potential energy is maximum, but at the middle, kinetic energy is maximum. At the extreme, x is maximum displacement. At the middle, x equals 0. At the middle, v, velocity is maximum. At the extreme, velocity is minimum or is equal to 0. Now, there is one more thing that I will do, which is acceleration. Now, remember that we said that acceleration is equal to w square x. That's the formula we got for acceleration using centripetal's acceleration. Now at the middle, at the middle, what is A? At the middle, x equals 0 at the middle. If x equals 0, then I will now be having A is equals w squared times 0. A is now equal to 0. So at the middle, acceleration is equal to 0. But remember, speed is maximum. What about at the extreme? At the extreme, at the extreme, we have x will be equal to a at the extreme. Therefore, a is equal to w square a. So it means that where you see a, it means that that thing is maximum. So at the extreme, A is maximum. So A is maximum at the extreme. So this has enabled us to do more showing what is minimum and maximum at the extremes and what is minimum or maximum at the middle. Now, after doing this, I cannot do it as a question. Just look at this. Look at this question. Look at this question. This is a very important question. This is a very important question. I want you to follow me as I take you through this question. Now, look at it. I have one, two, three, four, five. Now, what is the question in this five? Now, let me position this where this is the middle, these three. What is the question about these five? Question number one, at what point is displacement equal to, is displacement zero? At what point is displacement zero? The answer is at 3. Displacement is 0 at 3. At what point is displacement maximum? The answer is at 1 and at 5. Displacement is maximum at 1 and at 5. Next question, at what point is kinetic energy maximum? We said wherever velocity is maximum, that's where kinetic energy is maximum. So the answer is 3. But at what point is potential energy maximum? Potential energy are maximum at the extreme because that's where height is seen. So at 1 and at 5, potential energy is maximum. Where is acceleration maximum? Acceleration is maximum at the extreme, but speed is maximum at the middle. Acceleration is maximum at the extremes, but speed is maximum at the middle. Then they now ask you a question. Where is potential energy equals kinetic energy? Remember, potential energy is maximum at the extreme, kinetic energy is maximum at the middle. So as they are going like this, it's changing. Kinetic energy is changing to potential energy. Kinetic energy is changing to potential energy. As it's coming back, potential energy is changing to kinetic energy. So at 2 and at 4, at 2 and at 4, kinetic energy equals potential energy. Kinetic energy equals potential energy. So at 2 and 4, that's where both energies are equal because they are changing as they are moving. Now, take note also, one thing that you must know is that at 1, 2, 3, 4, and 5, the total energy is constant. The mechanical energy is constant. It does not change all through the motion. Thank you. Now, so far, these are some of the formulas that has been proven. So far, we began the topic now. Total energy, also called mechanical energy, is 1 over 2 Ka square. Remember, the K here is the spring constant, while the A here is the amplitude. Now, we had velocity for SHM is equal to angular frequency square root of amplitude squared minus displacement squared. We have angular frequency is equal to 2 pi f, which is also equal to 2 pi. Now f, remember, equals 1 over t. Is now 2 pi over t, that's over period. Then this again is equal to the square root of the spring factor or the spring constant over the mass, which is also called our inertia factor. Now we have this from circular motion, V equals angular frequency times radius. Now if you convert arrow to become A, it becomes maximum velocity. Take note, anytime you are dealing with maximum, you must say amplitude in your formula. So for maximum velocity, it is angular frequency times A. Unlike this, which is linear velocity, W arrow, this is now angular frequency times A. The same thing applies to acceleration. A is equal to W square arrow. Now, but when we are dealing with maximum acceleration, arrow becomes A, becomes W square A. Now, let's see how we can solve this or apply this in some of these questions. Question number one says, the velocity of SHM at point X from equilibrium position is given as this. Find the maximum velocity. Now look at it here. Find the maximum velocity and acceleration. What is the answer to this question? Number one, maximum velocity we said is equal to WA. Now the question is, where is my W in this expression and where is my A in this expression? Remember, this formula is this formula here. This formula is this formula here. So my W is my 4 and my A here is my 0.25. Now A square is equal to 0.25, W equals 4. So now I have it as, take note of this, W is equals 4, that's angular frequency, then my A square is equal to A square equal to 0.25. So if my A square equals 0.25, what will now be A? Therefore, A is now equal to square root of 0.25. So what becomes the square root of 0.25? A is now equal to 0.5. So now what is now our maximum velocity is now equal to 4 times 0.5. So my answer becomes what now? 2 rad per seconds. 2 rad per seconds. What's the next one? Maximum acceleration. A maximum is equal to W square A. That's our A maximum. So what's our W square? Angular frequency is equal to 4. What's our A is equal to 0.5. So this becomes 4 square times 0.5. So this becomes 16 times 0.5. So if you do that, what becomes your answer? You now have this, take this out, you bring this here, then this times this is 30, 0 carry 3, then 5 times 1 is 5, plus that's 8. So the answer is 8.0. So it's just 8 rad per second square. 8 rad per second square. So you see, no, question number one was asking us to find maximum velocity and acceleration. This is how it is solved. Now let's look at question number two. Let's see if we can take question number two here. Question number two says, what's the question number two? It says, a uniform harmonic oscillator has an angular frequency. Now remember, this is your W, angular frequency of 5.4 rad. 5.4 rad or the per seconds. It oscillates with an amplitude of 12 centimeter. What is the velocity at the point 4 centimeter from the equilibrium point? Now take note, this is our displacement. 4 centimeter from the equilibrium point is our displacement. 12 centimeter is our amplitude, while this is our W angular frequency. So now it means that I will say V is equals W square root of A square minus S square. So V equals, what's my W? My W is 5.4 equals 5.4 square root of, what is this? Now remember that if I convert this to centimeter, it will be 0.12. So this becomes, sorry, to meters, it will be 0.12. So 0.12 all in brackets squared minus, why this will be 0.04, 0.04 all in brackets squared. So now I will not say my V will not be equal to, so this will not be V equals 5.4 open bracket, the square of this will be 0.0144 minus the square of this will be 0.0016. So if you subtract this from this, you'll be having V is equal to 5.4 square root of this minus this will give you 0.0128. Now, what is the square root of this? V will now be 5.4 times square root of this will be times 0.113. So my V will now be equal to 0.61 rad per second. That becomes the final answer to this question number 2. Remember, I had to get all my factors from my question. This is my W at 5.4. This is my amplitude, while this is my displacement. Let's look at question number 3. Question number 3 says a particle performs SHM. The equation of the motion is given as this. This is the equation for the displacement of the motion, where x is the displacement, x is the displacement. If the displacement is 3 units, calculate the velocity. What is the velocity of an SHM? The velocity of an SHM is this. So we are using V is equal to W square root of A square minus S square. Now, if that is the question, that is the formula to use. We are looking for for V. So velocity will now be equal to, what is my W? In this expression, it will be easy to know all of this if I employ this formula that x is equal to A open bracket, A sine open bracket, WT plus or minus KX. Now look at this. In this formula, 4, A is my 5, sine to sine, 4 to W, T to T. So in this formula, this is displacement formula. Now I can tell you that my A is equal to 5 and my W angular frequency equal to 4. So if I come back here, what will now be my W? My W now from this equation is 4, that's 4, square root. What is my A? My A is 5. My A is 5 squared minus, what is my X? X was giving me 3 minus 3 squared. So V is now equals 4 square root of 25 minus 9. So V will now be equal to 4 square root of 25 minus 9 will be 16. Now, what is the square root of 16? V is now equal to 4 times 4. The answer is 16 rad per second. Now, let's see additional question. Question number 4. The velocity of system of mass 8 kg performing SHM is given as V equals plus or minus 6 square root of 25 minus 1. The total energy is dash. Now you see this formula given us or parameter given us can be compared. Now I'm solving number 4 can be compared with V is equal to W square root of A square minus S square. Now, what are we comparing with? We are comparing with V is equal to plus or minus 6 square root of 25 minus y. Now, please look at this. Sorry, there's a square here. Minus y square. Now, please look at this very importantly. The question says calculate the total energy. Now, what does that mean? Total energy. What is total energy? Total energy. Now, remember, it's one of the formulas I've told you to take note of. Total energy is a combination of the kinetic and the potential energy, and it's equal to 1 over 2 Ka squared. So, total energy is equals 1 over 2 Ka squared. That's the total energy. Now the question is, do I have K? Do I have A squared? Now if you look very well, comparing this with this, I know my A squared. My A squared equals 25. So I only have my A squared. I do not have K. So I cannot solve directly because I do not have K. But I have my A squared equals 25. W equals 6, S squared equals Y squared. So what will I do? I have to look for a way to solve for K. Now recall, what do I want you to recall? I want you to recall that W equals square root of K over M. Remember this formula, very important. So what becomes my angular frequency is equal to square root of K over, what is my mass? My mass in the question is 8 kg. So over 8. What is my angular frequency? My angular frequency can be traced from here, which is 6. So 6 is equal to square root of k over m. Now, sorry, k over 8, because my m now is 8. Remove this square root from there. I will now be having 6 square is equal to k over 8. So what is k? Therefore, k is now equal to 6 square times 8. What is 6 square times 8? So this will now be k will be equal to 288. Now if k equals 288, now remember that this is my real formula to solve, but k was missing. So I've gone to solve for k. My k is 288. So now my total energy is equals 1 over 2 times 288 times, what is my a squared? A squared is 25 times 25. So now if this takes off this, I will have 144. So my total energy is now equal to 144 times 25. The answer is now 3,600 joules. Remember, we are calculating for energy. So the answer is 3,600 joules. Now let's see question number 5. A body of mass, a body of mass 100 gram mass is equals 100 gram, which equals, convert it to kilograms, which equals, divide this by 1000, it will not be 0.1 kilogram. Now that's 0.1 kilogram, oscillates with SHM such that the acceleration is given by, this is the acceleration, A is equals minus 4y. Now, what is the actual formula for acceleration? Look at the actual formula for acceleration. A equals minus w square x, or minus w square x, not minus w square arrow, because this radius is displacement is arrow. So comparing this equation with A is equal to minus w square x. So if you are comparing this equation with this equation, you see that A equals A, x equals y equals x, y minus 4 is equals minus w square. Minus takes off minus, so the square root of 4 equals w. Therefore, W equals 2. So angular frequency or angular velocity is equal to 2. Now, what is my question asking us to find? So I have W already. I have my mass. My question gave me if the acceleration is 2. If the acceleration is 2 and the amplitude is 100 centimeter. Now take note of this, take note of this. Very, very important terms you must take note of. A, which is amplitude, equals 100 centimeter, which equals 1 meters. Take note of that. I'm converting everything to meters because acceleration was given me in meters per second square. Now, look at this. If A, now what am I looking for? Let me solve this. If A equals 2, so I can say vividly that I can use it anytime, but let us just hold it 2 meter per second square. What's our first question? Our first question says calculate the kinetic energy. What's kinetic energy? Kinetic energy is equals 1 over 2 mv squared. 1 over 2 mv squared. That's kinetic energy. Now, how will I solve? Remember, this v is the velocity of SHM. This v is the velocity of SHM. So, if v equals w square root of a squared minus s squared, what will that be? Ke. My Ke will now be equal to 1 over 2 dot m, then open bracket. What will now be my V? My V will now be equal to W square root of A square minus S square, all in brackets square. I want you to take note of what I've just done. My formula is 1 over 2 mv squared and v equals this. So I'm putting all of this in place of v, then I'm squaring them. Now, what will not be the final answer here or the final formula? It can be equal to 1 over 2m dot. Now look at this. This will times this to give me w square dot. Why this will cancel out this to give me open bracket a square minus s square. That's the formula I can use to solve this question. What is not this? This will not be equal to, let's bring it here, kinetic energy is equal to 1 over 2 times, what is the mass? The mass is 0.1, 0.1 times, what is W? W is 2, which is now 2 square dot open bracket. What is our A? A is 1 minus, what is S square? That's very important. How can I get S square? Now look at this from here. How can I get S square? A equals 2. We are told that acceleration is 2. So I will say 2 is equals minus W square X. So 2 is equal to minus, remember the minus sign is only showing us is going to an opposite direction, so I can still do away with it, is equal to, what is my W? My W in the question, my W is 2. So it now becomes 2 square dot x. So 2 is equal to 4 dot x. What is now x? X is now equal to 2 over 4. So this is equal to 0.5. So my x is 0.5, which is 0.5. Close the bracket. Now remember, there is a square here and there's a square here. So to solve this as a very important question, I will now have this cancels out this. Remember, this is 4. So to make it 2 cancels out 4 is remaining 2. So 0.1 times 2, that will now be 0.2. So I have it as kinetic energy is equal to 0.2 times. What is this? This will now be 1 minus 0.5, so in bracket 1 minus 0.25, close back the bracket. So kinetic energy is now equal to 0.2 times this minus this will now be 0.75. So what becomes our final answer now? Kinetic energy will now be equal to, equal to 0.15 joules. Now please check what I did here. I did not just solve with V equals what now equals W arrow or WA. No, I brought in the formula for speed of SHM. Why? Because the question is regarding us to use SHM speed to solve the question. So if you go down as I continue, you see that the answer is now what now? 0.1. Now let's look at the B part of it. The B part said maximum kinetic energy. Now remember that kinetic energy equals 1 over 2 mv square. Then from here we now say V equals W square root of A square minus S square. So therefore, what will now be kinetic energy maximum? It will now be equal to, we now have this at, now remember that at maximum kinetic energy, at maximum, where kinetic energy maximum, S becomes 0. So we now have X equals 0 for V to be maximum. Take note of that. So, or for KE for V to be maximum and KE to be maximum. Take note of these two. X is 0. So if X is 0, V will now be equal to WA squared. So this is the formula for V. So now I will now say kinetic energy maximum is equals 1 over 2 mv squared. What is V? WA squared. So kinetic energy maximum is equals 1 over 2m times, what is V? V is WA squared. WA squared. So this will now be equal to 1 over 2 times the mass. Remember the mass given us is 100 grams, which is now 0.1 kg, times 0.1 times our W in our question was giving us as our W in our question was giving us as what was our W again? We have it here as minus 4. A equals W square X. So remember, recall that W square equals 4. So W is now equals square root of 4 equals 2. So now this will now be this. Let me take it here. So kinetic energy is equals 1 over 2 times 0.1 times, what is my W? My W is now 4 times, what is my A in my question? My amplitude in my question. If the acceleration is this, and amplitude is 100 centimeter, that's our amplitude, 100 centimeter, which is written as 1, which is now equal to 1 what now? 1 square. That's our amplitude equal to 1 square. So this, we cancel that this to be 2. So I will now have kinetic energy is equal to, it's now 0.2 joules. So that's how you solve this. And the answer is 0.2 joules. Now I'll be looking at a simple pendulum where you have a bulb connected to a certain rope and it's oscillating to and fro. Is the equilibrium point. Now we said the time taken is equal to 2 pi root L over G. That's T is proportional to square root of L and inversely proportional to the square root of G. Take note of this. T is proportional to the square root of L, inversely proportional to the square root of G. So I can say T is proportional to what now? Square root of L. Now, if I want to solve this, it means that I can plot a graph. I can plot a graph of t against square root of L, and this is a straight line graph. Now, I can have t is equal to k square root of L. So, where my k will be equal to t over square root of L, 1 is equal to t over square root of L, 2. Now take note of this. Okay, let me do this again. I have k will be equal to t over square root of L. Now what is not there for? And I have t1 over square root of L1 is equal to t2 over square root of L2. This is in terms of period and length. What about for the next person or for the next factor? I can say t is inverse proportional to what now? Square root of g. So I will now be having t is equal to k square root of g. Cross multiply, I have t square root of g is equal to k. So therefore I have t1 square root of g1 is equal to t2 square root of g2. Now this is in terms of period and gravity. This is in terms of period and length. Now these are very important. Why? Because it helps us to know the various kinds of graph we can plot. So I can still plot a graph of t against 1 over root g, and it's also a straight line graph. Take note of this, it's very, very important. Now recall this, that um, if t equals 2 pi root L over G, look at this, it means that take this off. I will now have t square is equal to 2 square dot pi square dot L over G. So I have t square equals 4 pi square L over G. So if I have a graph, I can still have a graph of t square against L. So I can have t square is now proportional to L. So I can have a graph like this. These are possible graph. What is a graph? T square against L. Now, this will still be the graph, a straight line graph, but this time the slope of this graph, the slope is now equal to 4 pi square over G. That's the slope of this graph. Still a straight line graph, but 4 pi square over g. Now take note before we round up this. T is equal to 2 pi root L over g. What about f? F is equal to 1 over t. Remember, it should be equal to 1 over 2 pi root g over L. Take note of this. As you always take note of the period, take note of the frequency. So there are questions that you can use this to solve or this to solve as regards simple pendulum, and they are easy questions. Thank you.